Okay, section 3.5, number 5. Okay, so the directions for number 5 are use a truth table to determine whether the two statements are equivalent. So they want you to create a truth table for this statement, and then they want you to create a different truth table for that statement. And we'll know whether these are equivalent if what? If which part is the same? The last column. Okay, so if the last column in each table are the same, then they are equivalent. Okay, so how many different letters do you see? 2. So we need a P and a Q. And how many rows am I going to have? Okay, 4. So true, true, false, false, true, false, true, false. Okay, if we focus on the first statement here, we need a not Q. So that's the opposite of Q, false, true, false, true. And then I'm going to start with the first parentheses. If P, then not Q. Okay, so the P is the if part, and the not Q is the then part. And remember that the only time an if-then is false is when it's if true, then false. That equals false. So, and again, this is my if, and this is my then. So looking at if true, then false, right off the bat, that's false. If true, then true is true. If false, then false, that is true, because again, this is the only pattern that makes a false. So if it does not match this pattern, then it's true. Okay, if false, then true is true. This is the only pattern that's false because this was the only time in my example that I broke my promise, saying if you pass the final, then you will pass the course. And this statement says you passed the final, but you didn't pass the course. Okay, so this is the only variation that breaks that promise of the if-then statement. All right, looking at the next parentheses, if not Q, then P. So now we're reversing the order. And again, this is why I recommend pencil when you're doing this stuff so you can erase it. So this is now your if, and this is your then. So if false, then true is true. If true, then true, true. If true, then false, false. Oops, I looked at the wrong column, sorry. I looked here instead of here. Okay, so if false, then false is true. And then if true, then false is false. Okay, now I need to do the and statement between these two. So I'm looking at this column and this column, and an and is only true. They're both true. So here we have false, true, true, false. Okay, that's the first truth table. So now this truth table starts out the same, P, Q, And then I also need a not Q. But now I need the if and only if between that. So P, if and only if, not Q. And I am looking at the P column and the not Q column. And what do I know about if and only if? They're true if they're both the same. Good. So in the first row, they're different. So this is false. In the second row, they're the same. So this is true. In the third row, they're the same. So it's true. And in the fourth row, they're different. So false. Okay, so now you compare the final column of each truth table. And notice they are exactly the same, so this means that these two statements are equivalent. So same type of question, but this time we have if not P, then Q or not R, and then in parentheses R and not Q, then P. Okay, this time we have three simple statements, P, Q, R. So how many rows in our table? 8 is correct. Okay, so for P, the first half are true, second half are false. We have 4 truths in the first column, so we want to take half of that and do alternate by pairs. True, true, false, false, true, true, false, false. And then we start out with 2 truths in the second column, so in the third we want half of that to alternate. Okay, we need a not P. So that's the opposite of P. And then we also need a not R, so the opposite of R. Okay, so now I have to do what's inside parentheses. By the way, I purposely did my not P first because I wanted my if to be on the left-hand side, so that when I'm doing my if then, I'm going from left to right. But it doesn't matter what order you do these in. Okay, an or is only false when they're both false. Good. Okay, so I'm looking at these 2 columns. Okay, so this is true, true. Here they're both false, so that's false. True, true, true. Both false, so false, true. So then I need the if-then statement. If not P, then Q or not R. So this is my if, and this is my then. So if false, then true. True. If false, then true. True. If false, then false. True. If false, then true. Nope, this is still true. Pretty much if the if part is false, I already know it's broken the pattern. And so these are all true. Okay, if the if starts out with a false, it's the only time that it's false is that it's if true, then false. Okay, next row. If true, then true. True. If true, then true. True. If true, then false. False. And if true, then true. True. Okay, now we need to do the truth table for the other statement. I'm going to go ahead and use what I've already done so far. I'll just put a break in my truth table so I can clearly see that's my last column that I'm focused on. But I already have an R, and I already have, no, I don't have a not Q, so I need a not Q column. So that's the opposite of Q, which is false, false, true, true, false, false, true, true. And then I need R and not Q. So I'm looking at this R over here and not Q. So and is only true when they're both true. Okay, so false, false. Here they're both true, so true. False, false, false. Here they are both true, so true. And then false. And now I need my R and not Q, then P. Okay, so this time, this column here is my if, and the P is my then. So I'm going way back over here. And so again, the only time that an if-then is false is when you have if true, then false equals false. Okay, so if false, I already know that that is true. I don't even have to look over here because it's not an if true. Okay, so if false is true, if false is true. Okay, here I need to be concerned. So if true, then true, I'm still okay, that's true. If false is true, if false is true, if false is true, if true, then false is false. And then if false is going to be true. All right, so now I'm comparing these two columns. Are they the same? Yes. And again, I just took a shortcut and said I've already done the same work over here, so I just said all of these columns would have been the same if I repeated them. And so my final two columns are the same, and so therefore these two statements are equivalent. Okay, and then number 21, it wants you to write the converse, the inverse, and the contrapositive. And the statement is, if the stereo is playing, then I cannot hear you. Okay, so what keywords do you see in there? If then, okay, cannot, okay. So the not in there. For some of you guys, it might be helpful to translate this to symbolic form first, because then you can use the rules of how to rewrite all these pieces, and then after you've done that, then later put it back into words. Some of you can do it straight from the words, and that's fine. But if P stands for, so what's the first simple statement? The stereo is playing. And Q, I can hear you. Good. Then to translate this, we would have if P, then not Q. Okay, so if you're going to find the converse of this conditional statement, what do you have to do? Just reverse. Good. Okay, so the converse means reverse the order. So I'm going to have not, if not Q, then P. So in words, I would write, if I cannot hear you, then the stereo is playing. So all I did was reverse the order, but when you do this, make sure that you put the if on the right. Some people just rewrite it like this. I cannot hear you if the stereo is playing. That's not the converse, that's the same sentence. Because the if, you kept it with the same item. So make sure that you've rewritten it where the if goes with the other part. All right, the inverse, what are you supposed to do to your original conditional? Negate both sides, good. So this becomes not P, and the not Q becomes Q. So if the stereo is not playing, then I can hear you. Okay, contrapositive. So what are you supposed to do to the original conditional statement? Reverse and negate. Good. So reverse the order and negate both sides. So we're going to start out with Q. If Q, then not P. Okay, so if I can hear you, then the stereo is not playing. Well, the rules refer to the original. What you're going to do to the original. Yeah, if P, then not Q is the original. So you're supposed to reverse it and negate both sides, which is what we did here. Okay, so in 3.6 we learn a little bit more about some of the equivalent statements that you can form. So we're going to start out with the negations of conditional statements and De Morgan's law. So if you have an if-then statement and you want to form the negation of that if-then statement, then you're going to change it to an and statement. So the negation of if P then Q is P and not Q. Now the way that helps me to remember this is if you think about the only time that an if-then statement is false is when the if is true and the then is false. So look at what I just said and look at the statement on the board. When the if is true, notice that the P stayed the same, the if stays the same because it's true, and the then is false, and so notice I changed the negation of the then because we're saying it's false, because we're trying to find the negation. So if the if-then statement is true, the only time that's going to be a false is if we have P and not Q. Now, another way that I can write this symbolically, instead of using the word negation like I have here on the slide, is if I use it symbolically and use the negation symbol outside parentheses. So that first sentence and this symbolic is the same exact thing. I have the negation of if P then Q is equivalent to P and not Q. So let me give you an example. If it is sunny outside, then I go to the beach. If it is sunny outside, then I go to the beach. I could say, it is not true that if it is sunny outside, then I go to the beach, right? That's how this first one would translate, the negation outside parentheses. It is not true that if it is sunny outside, then I go to the beach. Another way I could say that is, it is sunny outside and I did not go to the beach. Okay, so notice how that gives you the opposite truth. I said that if it's sunny outside, then I go to the beach. Well, it's sunny outside and I didn't go to the beach. So what I said was false. So it's an equivalent way of saying that if the negation of the if-then statement. Okay, so we're going to prove that these two statements are equivalent, and the way we learned how to prove it is to make a truth table for each statement. So on the left, drew a truth table for that one with the negation outside parentheses. And on the right, do a truth table for the P and not Q. Okay, I don't think I gave you much help on these truth tables on your handout. I just put a P and a Q, and you got to fill in the rest. So I'm trying to get you guys more in the mode of doing these from scratch on your own. Let me set up the first table for you. So you've got P and Q. Then you have to do what's inside parentheses, if P then Q. And then you want the negation of what was inside parentheses. Okay, so again, it's like order of operations. You do what's inside the parentheses and work your way out. So for the truth table on the right, you still have a P and a Q. But then you have to do the not Q that's in the statement. And then you do the and statement between the two. Okay, it's really important that you can do these truth tables without any help, because on a test you're going to have to do a couple of truth tables from scratch in the non-multiple choice section. Hopefully this is what you got for the first truth table. Any questions on that? Again, a lot of people get tripped up by the negation outside parentheses. You always have to do what's inside parentheses first, and then when you get to the negation, it's just the opposite of what you did for what was inside the parentheses. And the only time this if-then is false is right here, because this was the if and this was the then. So that was the only time you had if true, then false equals false. Okay, leading to right there. And then your other truth table, the not Q is just the opposite of Q. And then you have an and statement between the column for P and the column for not Q. And is only true when they're both true. So in that second row, that last column right there, that's the only row to have a true. So now when you compare the last column in both truth tables, notice that these last columns are exactly the same, false, true, false, false. So we just proved that these two statements were equivalent. Once you know that two statements are equivalent, then you can always rewrite the sentence to match that. Okay, you don't have to do a truth table anymore because you've already proved that those two are equivalent. And these would be the types of things that I would put on my note card, especially if they're hard for me to remember which one was equivalent to what. Okay, that'd be the type of thing that I'd look for. Hopefully the stuff like an and is only true when they're both true, hopefully that's stuff I don't need to put on my note card, because I've been saying it to myself over and over so many times. That's why I keep saying it and have you guys repeat it, because the more you do that, hopefully that's the stuff you remember. So if you put too much on your note card, you might not find it on test day because it's overload. So you want to look to see what are you always remembering. You don't need that on your note card. Now, if you have test anxiety and you tend to blank out, then you might need those little things on your note card as well. But again, keep in mind, the more you have on your note card, the harder it's going to be to find stuff. Question? Okay.
So the answer is the P, the negative P.
If you're ever asked to find the negation of an if-then sentence, the goal is that they want you to change it to an and sentence. That's really the point of this slide. If they ask you to find the negation of an if-then sentence, change it to an and statement in the same pattern that we did here. The if part stays the same, the then part gets negated. Okay, De Morgan's law. You saw this in Chapter 2, and this is how you saw it in Chapter 2 with set theory. In De Morgan's law, we learned that if you have the complement of an intersection, then it was the same as if you distributed that complement symbol and flipped the intersection into a union. Okay, hopefully that's looking somewhat familiar from Chapter 2. Well, De Morgan's law also applies to logic. Now, the intersection symbol is the same as what word in English, other than intersection? And. Okay, so we could rewrite this with logic with an and symbol. The union symbol is the same as or. And the complement, we talked about it being the opposite of what was inside the set. In logic, the opposite is the negation. Okay, so consider if we wrote it this way. The negation of an and statement is equivalent to if you took the negation of both pieces and changed that and to an or. So notice it's a similar process to what we did up here. It's as if you distribute that negation symbol and flip the and into an or. We are going to prove that these two statements are equivalent. And what do we use to prove that statements are equivalent? Truth tables. Okay, so if you have your handout, then you already have a table drawn there. But it doesn't really have anything in it. You have to fill it out. And so on the left, do a truth table for that statement. So even if you don't have the handout, you're doing a truth table for that statement on the left. On the right, do a truth table for that statement. Okay, so your truth table on the left should look like this, where you first do what's inside parentheses, and then the negation outside parentheses just means take the opposite of what you just did in parentheses. And then your truth table for the right-hand side should look something like this. So you have to do each of those little negations first, and then do the or statement between them. And remember that an or is only false when they're both false. So notice that the last column in both truth tables are the same. So we just proved that these two are equivalent. So an example would be, it is not true that I like green beans and I like peas. It is not true that I like green beans and I like peas. I could say the same thing by saying, I do not like green beans or I do not like peas. See, if my and statement is false, then that just means that it was one or the other. I just needed to say I don't like one or I don't like the other, and that would prove that it was false. Okay, De Morgan's law, though, also had that if you had the complement of the union, that was the same as taking the intersection between the individual complements. So again, the union is the same as the word or, and intersection is the same as the word and. The second one was a little easier, huh? Okay, so you can rewrite this in logic, symbolic logic, by having a negation outside parentheses, P or Q, and that is equivalent to not P and not Q. Okay, so go ahead and fill in a truth table for the statement on the left that has parentheses, and then go ahead and do a truth table for the statement on the right that has no parentheses. Okay, so hopefully the more you do truth tables, the faster you get. I see that some of you guys are completing these a little bit faster now. And so your first truth table should look something like this. Doing what's inside parentheses first. So the or statement is only false when they're both false. So that third column was true, 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 false. And then the opposite is false, 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 true. So then your second truth table, you needed a not P, and then the not Q. And then an and is only true when they're both true. So in the last row was the only place that those two columns were true. So false, 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 true. So notice that the last column in each truth table are the same, which they should be because we already stated that these were equivalent.
So in the and, false and false is false?
Yeah, in the and statement, the only time that it's true is when they're both true. A couple problems in 3.5 that I told you guys to skip. Okay, so it wants you to select the statement that is equivalent. Here's the statement to I saw the Titanic or born supremacy. So what's the key word in that sentence? Or. And so it wants what's equivalent to this. So if you recall from last time, P or Q was equivalent. Anybody remember from last time? So this would be something you want to put on your note card. It was an if not P, then Q. And really, it doesn't matter which one you choose for your if part. Just pick one of these statements and make it an if not, then the other side. So you could have also had if not Q, then P. So if you have an or statement, pick one of the sides. It doesn't matter which side. And then that side is going to be your if statement, then you have to negate it. If not one of those letters, one of those simple statements, then the other one. Because here's how this works. If you have an or statement, that means that you did one or the other or both. Well, if you didn't do one of them, then that means you must have done the other for that or statement to be true. So it doesn't matter which one you don't do, okay? If you don't do one of them, you have to do the other. Okay, so you have two choices for your answer. You just got to make sure that you pick the right one there. I saw both the Titanic and born supremacy. Well, not necessarily, right? So here's our answer. It gave us an and this time. You may have seen one or the other or both. It's not a guarantee that you saw both, so you can't say that that's equivalent. If I saw the born supremacy, then I did not see the Titanic. If I saw born supremacy, I did not see the Titanic. Not necessarily, because you could have seen one or the other or both. So just because you saw one doesn't mean you didn't see the other. If I did not see the Titanic, I saw born supremacy. Okay, notice that that one does follow this pattern right here. If I did not see the Titanic, I saw born supremacy. So that is equivalent because you did one or the other or both. So if you didn't do one, then you did the other. And then notice that D is the same as B. They just reversed which movie. If I saw the Titanic, I did not see born supremacy. Again, not necessarily. Okay, so be careful with these or statements, because one of the things we learned about or is that it could become an if-then. Okay, so the answer this time was C. Good job. I'm going to pat myself on the back because nobody told me what the answer was. So. All right, so we want the statement that is not equivalent to the following statement. So you got to really pay attention to what it's asking you. This time you don't want the equivalent. So that means 3 of these are equivalent to that statement and 1 of them is not. So what are the key words in this sentence? It is not true that Charles Schulz did not write a sonata and Snoopy danced a jig. Okay, so what key words do you see? Okay, so and it is not true that. Okay, not. All right, so in this particular instance, P would stand for Charles Schulz wrote a sonata. And Q, Snoopy danced a jig. This sentence would make more sense if you knew who Charles Schulz was. Anybody know who Charles Schulz is?
He's the guy who made Peanuts.
That is correct. He is the guy who created Peanuts, which Snoopy is in. Okay, so. All right, so this is how this sentence translates. It is not true that, negation outside parentheses, Charles Schulz did not write a sonata, so not P, and Snoopy danced a jig, Q. Okay, so one of the things that would help you to know which one is not equivalent is if you know what is equivalent, because then you can eliminate the ones that you know are equivalent. Notice that you have a negation outside parentheses, and inside parentheses is an and statement. So notice that you could use De Morgan's law to figure out another equivalent statement to it. So it's as if I distribute this negation and flip this. So the negation of a negation just brings me back to the actual simple statement. So P, the and flips to or, and then this becomes not Q. Okay, so this equivalent is this statement is equivalent. So was that one of your choices? So this would translate to Charles Schulz wrote a sonata or Snoopy did not dance a jig. Okay, which letter is that? A. Okay, so we can eliminate, I guess there's no letter, huh? First choice, okay. We can eliminate that first choice because that is one of the equivalent statements. Now, notice that we have an or statement. We just discussed in the last problem that an or statement can be rewritten as an if-then. So if I start with this P or not Q, there are 2 ways that I can rewrite this as an if-then. So remember, pick one of the sides. If that's going to be your if part, you have to negate it. So let's say I start with P. Right, it would be an if not P, then leave the other side just as it is. So not Q. Okay, so here's one of my choices. So if Charles Schulz did not write a sonata, then Snoopy did not dance a jig. Is that one of the sentences there? The third one. Okay, so I can cross out the third one. But I could also pick the other side to be my if. So if I started with the not Q, and that's my if, then that not Q is going to switch to a Q. So if Q, then leave the other side the same. So P is going to stay the same. Now notice if you just compare the 2 if-thens, I also just wrote the contrapositive, which I know is equivalent. So I could also think of it that way. The contrapositive of that if-then is going to be equivalent. All right, so this would be if Snoopy danced a jig, then Charles Schultz wrote a sonata. Is that one of my choices? Yeah, that's the last choice. Okay, so notice that I eliminated all the ones that I know are equivalent, which leaves me to the actual answer that is not equivalent. So the more you know all of these patterns, that makes it a lot easier. Now, worst case scenario, you only eliminated 2 of your choices and you're not sure which ones to choose. Well, then you could do truth tables for all the ones that are left. Okay, and then the truth tables that don't match are the ones that are not equivalent. In 3.6. So for this one, it wants you to write the negation. If it is purple, then it is not spinach. If it is purple, then it is not spinach. So what are my key words? Okay, I heard if, then, and not. Good. So I could translate this. If P is it is purple, if it is purple, then, and Q is it is spinach, so not Q. So I could translate it like that. Okay, it wants me to write the negation of this. So one of my choices would be to write it like this and stick the words, it is not true that, in front of my statement. Now, is that any of my choices with an it is not true that? No, because that's sort of the cop-out way of doing the problem, right? Sticking an it is not true that in front of it. So instead, we have to remember what was equivalent to it is not true that if P, then not Q. There was an and statement, right? And so when I had the and, did the if part stay the same or negate? Stayed the same, good. So P and then if did the then part stay the same or negate? Negate, good. P and, so instead of a not Q, I need a Q. So this is what you're looking for, P and Q. So I can eliminate the one that says or. Okay, I'm not changing it to another if-then. And so notice my 2 choices that are left. It is not purple and it is spinach. Nope, that's not it. It is purple and it is spinach. That's the one I'm looking for. And then you're going to have some problems that ask you to use De Morgan's law. And let me show you one of the most complicated problems. It's just going to be in symbolic form. Fantastic. See, we got a fantastic before we finished here. Okay, I want you to write the negation of the following statement. So here's the original statement. And I want you to write the negation of this. Well, symbolically, the easiest way to write the negation would be to put parentheses around it and put a negation symbol in front of it. That's the easiest way to write the negation of something. But what they want you to do is write it as simplified as possible with the least amount of grouping symbols that you need. So notice that inside I have an and statement. So I can use De Morgan's law. Only if it's an and or an or in there can you use De Morgan's law. So De Morgan's law says, okay, distribute that negation symbol. So the negation of not P is going to change to a P. The and is going to change to an or. And then I have a negation of this entire parentheses. Nothing inside parentheses changes because I didn't attack that one. It was just each side of the and. But notice I now have another negation outside parentheses. So now we can use De Morgan's law again. So take this, and it's as if you're distributing and flipping this symbol over. So I did not change the P or, but now I have a not R. The or changes to an and the not Q changes to a Q. Now, the only tricky thing is that I still need parentheses around this because in the original it had parentheses. The and is what split it. Remember right here? The and is what split those two sides. So you're still splitting it on the same symbol there, and you need parentheses. Question?
How come the R didn't change to not R? Oh,
It did in the last one. It didn't do anything here because we just had to put the negation in front of the parentheses first.
the question is, how come it didn't change to positive, just to R instead of negative?
Well, because it had just an R in the original, so then we had to apply the negation to that, which left us with a not R. Okay? Another question?
I see that, like, basically every symbol was switched from the original to the last one. Would it always work?
Okay, well, it always worked where all the symbols switched, only if you had ands and ors in everywhere. If the second parentheses had been an if-then, well, then you would have had to take the negation of an if-then for that second parentheses. So, yeah, so it all depends on what you have in there. So, good question.